Hi there, welcome back to another video from the Math Doc. We're continuing with our series on inequalities, and this video focuses on double inequalities. Double inequalities are sets of inequalities that are shown or set up in series, just like this example here, where we have -2 is less than x, and then we have x is less than 2, and they're all written up in a series. And obviously there has to be some kind of consistency so that this works and this works. And what that means is that both parts of this inequality have to be satisfied at the same time. And that basically means that we have once more a compound inequality with an end requirement. And if you want to be reminded of that, of what that means, you can look down in the comments for the link to the video on compound and inequalities. But basically, we're looking at a set of more than one inequality. They are set up in series, and therefore they are bound in this setup with an end requirement, which means that both inequalities have to be satisfied simultaneously. In this simple example, we can see this on the number line. We have x between larger than -2 or and smaller than 2. Definitely not or, but and smaller than 2. So we have -2 here, and we have +2 here, and x can be anywhere in between these two numbers. So x is somewhere in the interval between -2 and 2, and we do not include the boundaries in this case because we don't have a less or equal to, but just a less than. So this demonstration, this example is really very simple, but we're going to move on to a couple of more slightly more complicated examples so that you can get a good feel for what this actually ends up meaning. So this example is just a little bit more complicated than the previous demonstration. We just have to do a little bit more work in order to isolate x and find the values of x that will satisfy this double inequality. So remember again, what we like to do is we like to isolate our variable x. And in order to do that, we have to do something with our 4 here. Well, naturally, we would like to just subtract 4 from this part of the inequality, but we have to also subtract 4 from this part on the right and also on the part on the left. So just like we do for a regular inequality, we will subtract the same expression from all parts of the inequality. Let's do that. So -4, -4, and -4. And we end up with 16 minus 4 is less than 3x plus 4 minus 4 is less or equal to 19 minus 4. Okay, 16 minus 4 is just 12. 3x plus 4 minus 4 is just 3x. The two 4's cancel, and that is less or equal to 19 minus 4, which is just 15. We have to take one more step in order to isolate x, and that is to divide by 3, right? We'd like to get rid of that 3 here. So let's divide, again, all 3 expressions by 3. So we always have, whatever we do to the inequality or double inequality, we have to do it to all sides of the inequality or all expressions in the inequality. So we have here on the left 12 divided by 3, that's just 4, less than 3x divided by 3 is just x, right? The two 3's cancel, less or equal to 15 divided by 3, which is just 5. So we have x is less than 4 or less or equal to 5, and let's put that down on the number line, although it's quite simple. We have a 4. We have 5. 5 here is a filled circle because we have our less or equal to, and it's this interval between 4 and 5, including the boundary at 5. So that these are the x's that satisfy our inequality here, our double inequality. And remember, when we have a double inequality, it is a special case of the end in compound inequality set. So we have to satisfy both of these inequalities. Let's take a look at one more example. And this example will be a little bit more complicated. It'll show us that we have to break up the inequality, the double inequality, in order to solve it. Okay, so what do we have here? We have this double inequality, x minus 4 is less than 3x is less or equal to 12. Okay, so what we have here is we have x in both the left and center sections of this double inequality. And this means that we'll have a little bit of a problem to isolate x into just one part of the inequality. If we do minus x, say here, like we take minus x, minus x, minus x, we will remove the x from the left-hand side. We'll remain with minus 4, and then in the center we'll have just 2x, but then on the right we'll have 12 minus x. So we haven't achieved anything because we just moved that x from one side to the other, but we haven't isolated the x to one part of the inequality. Well, as a reminder, double inequalities are special cases of compound end inequalities. So let's look at this again, and let's try to separate this into a set of two simple inequalities that are compound with the end requirement. So what do we have here? Let's separate them with using two different colors. On the left-hand side, we have x minus 4 is less than 3x, right? That is our first inequality. What is our second inequality? Our second inequality is that 3x is less or equal to 12, right? But we have to remember that these two inequalities are combined with an end requirement. So we will solve each one of them separately, but then when we look at the solutions for the double inequality, we have to remember to combine them with an end requirement, which means that we can only look at the x's that solve for both. So let's go ahead and solve this first one on the left. Here we have x minus 4 is less than 3x. So in order to isolate x, we should probably subtract x from both sides, right? That way we will remove the x from the left side. Okay, we have x minus 4 minus x is less than 3x minus x. Okay, the two x's on the left do cancel. We have minus 4 is less than 3x minus x is just 2x. Let's take that last step of dividing by 2. Okay, and we are left with minus 4 divided by 2 is just minus 2. Is less than 2x divided by 2 is just x. Okay, so on the number line, we see that we have x is larger than negative 2. Okay, right there. So for any x larger than negative 2, this first side of the inequality is satisfied. Now, let's go on and solve the right-hand side. So we have 3x is less or equal to 12. Let's divide by 3. And we have x on the left-hand side, right? 3 divided by 3 is just 1, is less or equal to 12 divided by 3 is 4. So the right-hand side, we have, here's 4, and for any x less or equal to 4, this requirement is satisfied, okay, this inequality. So we're back at the situation where we have a compound inequality with an end requirement, right? So here we have to make sure that we're satisfying both. Which x's satisfy both? Well, it's just the x's right here between 4 and negative 2, because these x's both satisfy the requirement to be larger than -2, and the requirement to be less or equal to 4. So our x's are between -2, and +4, including the boundary at 4. So for any x within that interval, we satisfy this compound inequality, which was written up initially as a double inequality right here. So that's it for this video about double inequalities, which again are a special case of compound end inequalities. If you want to review these, there'll be links below to the end compound inequalities as well as the or compound inequalities. If you have any comments or specific questions, please include them below. I'll be happy to answer and respond or set up another video with examples. See you next time.